All right, so we're starting note 17.2 today. These are angles formed by secants and tangents. And let's just review what a secant and a tangent is. Remember, a secant goes through the circle like this. A tangent just touches it at one point, the point of tangency. We're going to see how those affect some stuff. But first, let's remember a couple of things. It says find the value of x. Well, x is a central angle. Its vertex is at the center, so its length, or its degree measure, is the same as its intercepted arc. Well, I don't know that, but I know everything else, but that's 200. So of course, we can do 360 minus 200 to get that arc length, which is 160 degrees, which means that x is also 160 degrees. So pretty easy one there. Central angles equal to their intercepted arc. The next one is not a central angle, it's inscribed. It has 3 points on the circle. Its vertex is on the circle. It has 2 chords. And if you remember, this x is half of its intercepted arc. Now they kind of gave it to us lopsided. I can find this arc by doing 360 minus 140 minus 170. And when you do that, you get 50 degrees. Well, inscribed angles are half their intercepted arc. So half of 50 would give us 25 degrees. So if you want to write something out for that, because we just learned that, the inscribed angle equals 1/2 its arc. Okay, so that's some review. Let's look at some stuff that's going to happen today. We've got a theorem that's pretty important. It says if a secant and a tangent intersect at a point of tangency, so if they touch where that tangent line hits the circle, then the measure of each angle formed is half the measure of the intercepted arc. So let's look at this one. Here's my tangent line from the point of tangency. Here's my secant. In this case, it looks more like a chord. This angle is always half of the arc that intercepts. Okay, so if we can find that arc right there, we can find everything else. Now this one's kind of working backwards. It says the angle on the circle equals 1/2 the arc. Well, I have the angle on the circle is 30. So that equals 1/2 of the arc. In this case, it's x. Well, I can fix that real quick by multiplying by the denominator. And I get that 60 equals x. So x is 60 degrees. You probably didn't need to write that out to figure that out, but mine as well. Let's go to the next page. Quick, if I flip back to this one, this angle was 30, so its arc was twice as big. So this problem is pretty similar to the last problem. It's given us an angle formed by a tangent and a secant, and then it's giving us an arc, but it gave us an expression instead. So just you can kind of use that here. So if this angle right here is 89, then the arc is twice that, so it's 178 degrees. Now I know this expression equals 178, and I can solve for x. So 11x plus 2 equals 178. Now be careful at this spot. We just took a test, and I've seen a lot of people that are not solving quite correctly. Remember, you're subtracting this from both sides. So 11x equals 176. When you divide both sides by 11, I got x equals 16. And that was the bell in the video, not the bell in your class. So guys, remember, this one can be kind of tough. If you have that angle formed by that secant and tangent, then that arc is double that angle, okay? Let's look at another theorem. This one's kind of long. If two secants intersect on the interior of a circle, then the measure of the angle formed is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So that can be very confusing. Here's a picture, and there's a little formula. When they're talking about the angles inside, they're talking about these two angles right here, okay? Those are vertical angles. They're the same thing, but they cut out different size arcs. This angle over here on the right cuts out a 30-degree arc, and this one cuts out 70. Now remember, this isn't a central angle, so those angles aren't 30 and 70, okay? Well, what it's saying that you do is you take those arcs you add them up and divide it by 2. And then that's how you get your angle. So it's saying that that x is going to be equal to 70 plus 30 divided by 2. 70 plus 30 is 100, and 100 divided by 2 gives me 50. So I know that x is 50 degrees, okay? So it means add up those arcs and then divide them by 2. The next one's very similar. If two secants, a secant and a tangent, or two tangents, so there's 3 ways this could happen. You could have two secants, secant and one tangent like we've already seen, or two tangents intersect outside of the circle in the exterior, then the measure of the angle formed is half the positive difference of the measures of the intercepted arcs. This one is a handful, okay? It's not really hard, but it can be kind of tricky, especially with that wording. Here I've got two tangents, and they intersect outside the circle. It's the only way two tangents could do it. However, this could happen another way. I could have one tangent and a secant intersecting outside, or I could have two secants intersecting outside. It all works the same way, okay? Basically, what we're going to be talking about in all 3 of these is 2 of the arcs and the angle. 2 of the arcs and the angle. In this case, 2 tangents, I've got one arc right here that says it's 150. Then I have this bigger arc on the outside that we can find. So let's do that first. That's the easy part. So I know there's 360 degrees in that circle, and I don't want the 150 degrees. When I subtract those, I get my arc length of 210 degrees. Now it says right here, this is the outside angle. Okay, that's what it's talking about here. I'm going to put x. What it says is half the positive difference. So we're going to divide whatever we do by 2. But what you always do here is take your big, and I'm going to kind of change this, big arc, the larger of the arc, minus the small arc, okay? So this is going to be 210 minus the 150. Well, 210 minus 150 is 60, and 60 divided by 2 gives me my angle of 30 degrees. Now, it's not really tough to do, but we're going to have to work it backwards in a second. That can be tricky. So it's always the difference from the biggest minus the small divided by 2, okay? Let's look at the next one, see what we got. Now this one is very similar. This time though I have a tangent intersecting a secant outside the circle, but they actually gave me that outside angle. They gave me one of the arcs and they want me to find the other one. Now the picture can be a little bit confusing. I think what it's saying is we've got, see that little dash there? We want to find the measure of this arc, but we know the measure of this arc, okay? Those are the 2 arcs. We got a bigger one and a smaller one. They're between those lines. So this time, though, I know my angle. So 40 equals, well, I want it to be the big minus small. So it looks like 150 minus x divided by 2. So we got to do a little algebra here. First, let's clear the fraction. Let's multiply both sides by 2. 2 times 40 gives me 80. That leaves 150 minus x. Now you can solve this however you want. You could subtract the 150 to both sides and divide everything by -1. You can move the x. So what I'm going to do is I'm going to add x to both sides at the same time as I subtract 80. So the x moves over here and end up with 70. So x is 70 degrees. So the work's always going to be the same too, guys. It's divide by 2. Multiply both sides by 2 and you should be good. Then the last one in my most favorite, the exact same problem, except this time they've given us some expressions. So you got to remember, here's the angle, here's one of my arcs, the smaller of the 2, here's my big arc. I just need to fill out the equation and solve. So first, I need my big arc minus my small arc. So 4x plus 5 minus 50 divided by 2, and that should equal x plus 25. So I have my angle goes right there. This other expression went in the top where the arcs went. Same thing as last time though. I can clean this up a little bit by multiplying both sides by 2. And I'm going to go ahead and combine some like terms here. I'm left with 4x minus 45 equals, don't forget to distribute, 2x plus 50. I can move my 2x over. And at the same time, I'm going to go ahead and add my 45. And I end up with 2x equals 95, and of course that's going to be a decimal, and that's okay when I divide both sides by 2. I got x to be 47.5. Now I didn't say plug it back in. It could have asked for that other arc, but it didn't, so we just have x. So guys, here's those 3 formulas kind of all together. Remember, we can say big minus small here if you want to. The addition, it doesn't matter. They're all pretty easy once you practice them, but if you're not going to do your homework, then it's going to be kind of rough. So get that stuff done. If you have any questions, just let me know tomorrow. Good luck.